Hey everybody, welcome to the Joy of Coding. Appreciate everybody joining us tonight. It's Monday. We're starting a new week. We got some interesting stuff coming up this week. This week is all about pair programming. So we're going to be seeing how two people can put their brains together to work together on solving a problem. And not only do we study pair programming in this class, we do pair programming in this class. This is how we learn. I found that it's a really good way to explore and experience in a very practical setting. So tonight we will get an introduction to it in something that I call an operating theater exercise, where oh, actually, it's not the right screen I want to share. Let's share. Nope, don't want to do that one either. We'll just put that away. There we go. There's tonight. Nope, that wasn't the right one. I wanted the other one. Here we go. That's the one for tonight. We'll minimize the other one. Hey,
Sorry, sir.
nope.
I'm taking a trip and I'm late.
Just cutting through glass. Okay. Ah, 5 points from Gryffindor. Okay. Called me sir. So polite, these kids. Anyway, so we're going to do some pair programming tonight. And I'll be one of the pairs. I'm going to ask for volunteers, and if we don't have enough folks, I'll be voluntolding some people to spend 7 minutes pairing with me. I think it'll be a good way for some of you to gain individual experience, but then everybody to see what the dynamics like, what how to sort of what it might feel like. Because then on Wednesday, you're all going to be doing it yourself. So just as a reminder, Wednesday is the first of 3 times I ask that I require you to be in the classroom. There is not a Zoom option for Wednesday, and so if you can't make it, I know a couple of you reached out to me saying you can't make it. Great, or rather, not great, but it's like, yep, we dealt with it. We've come up with an alternate thing that you all can do. And everybody else, please be in class. Bring your HDMI adapter. We have this great classroom where we have 4 stations, and so with four pairs, I think that'll make for a great experience. So tonight we're going to talk about again an introduction to pair programming. I know I've got a couple of handouts that I didn't get through last time. I want to do the pairing stuff first. If there's time, we'll talk about the handouts. Otherwise, I'll record a bonus screencast because it's mainly me talking to you about things. We don't need to spend precious class time doing that. I can record it and you can watch it on your own. Let's see here. Also, this week, the Java koans are due on Wednesday. I hope that you've gotten a good ways into it because it's almost done. We also assigned project one last week, so work is starting to come into progress. So please finish off the koans. There's also the second quiz is due on Wednesday also. Oh yeah, and also tonight we'll be assigning project two, just so that people can get a feel for what is coming up, so that you can start planning out your next couple of weeks in terms of how you work on your projects. But before we dive into pairing, I wanted to open up the floor for anything you'd like to discuss. Has anything come up over since we last met on Wednesday that you wanted to discuss? Things you want to let me know about? Any questions on your mind? Any ideas for what we can be doing? Okay, then let's dive into it. Pair programming. So I've got this page here. I don't think we're going to be editing it tonight, but if you want to follow along, this is sort of well, I don't know, my lesson plan. I'm just going to do fit. That's nice and big. We can see that. This is what I want to talk to you all about tonight with regards to pair programming. So, in the first 2 weeks of the course, we began learning about test-driven development. So this is an approach to development that really focuses on the results of what you need to write and validating that the code that you've written produces the right results by writing the test first and really orienting around what you ultimately implement towards the goal of making a test pass. And tonight, we'll continue to explore test-driven development in the context of pair programming. I've got a few words to say about pair programming, what it's all about. There's also a lecture that an associated screencast that I hope you took the time to review. I'll say a couple of highlights about it here to get us started and get us oriented. But then we'll spend, I don't know, 45 minutes or so of class tonight pairing, in which I'll ask for volunteers to pair programming with me on a simple kata. It's FizzBuzz, you've probably heard about it. Or if you haven't, you'll understand it really quickly. It's a good way to get started. On Wednesday, you'll all be doing pair programming on your own. You'll be doing a code kata called Leap Years, again, to learn about test-driven development and to learn about pair programming with someone else, how to collaborate with somebody on a small programming project. And then we'll have a second pairing activity a week from Wednesday, where you'll do another kata. So, um, when it comes to the katas that we write in class, and katas are these little coding exercises. Those katas, we'll all implement them in the same GitHub repository. When I started doing this several years ago, I had each pair create their own repository, and that took up a lot of class time, and people encountered problems, and it was just kind of a pain in the butt. And so then I decided, well, hey, let's have everybody contribute to one repository. Which actually made for a really interesting learning experience because we have, whatever, 10, a dozen, more students contributing all to the same code base. And so then, you get to experience what it's like to be working in a repository along with other people. And especially everybody kind of working at the same time, which can lead to some interesting results at times, and good learning. I think the winner for best learning experience goes to the group that I had in the winter, where in the middle of the first pairing assignment, someone did everything and deleted all the code in the assignment. It was pretty amusing. And of course, with GitHub, it's got the Git history, so we know where all the bodies are buried, and no shame in it because we ended up having a really good learning exercise. We talked about what happened. We kind of blew the whistle on the pairing. We went through and tried to recover things. People, really got a good understanding of, what it means to collaborate with a lot of people. So anyway, so if you would, let's see here, I posted about some stuff about this over the weekend, but I would appreciate it if you could follow along with me right now. And if you haven't already, please make a checkout of this repository. I will post the link here in chat. Please make a oops, local clone of this. Oh, and by the way, please do the clone in a directory that's not already a checkout of like your summer 2020 of your of your Joy of Coding summer 2026 repository. Don't have one GitHub repository in the same directory as inside a checkout of another one. It really confuses Git. It'll confuse IntelliJ. So please have them, if you want them close to each other, please have them in the same parent directory. The same way that with me, when I have all my code, all my checkouts in this, Git, PS, my home directory, PSU, Git, Joy of Coding PDX, and then, Kata Summer 2026. If you then look in if you look in the parent directory, you see it's got, all the times that I've got this, including, some other stuff in there too. So this is how I like to keep my repositories organized. Again, please don't do something like, go to your like your own Joy of Coding Summer 2026. Don't do the checkout from in here. Check out the other repository in this directory. It'll confuse things. Okay. And the reason that I'd like you to make a checkout of that repository is I want to make sure here and now at the beginning of our pairing that everybody can commit to this repository. I created this repository over the weekend, and I believe I've added all of you as a collaborator so that you can commit and push to the repository. This will, so let's validate that now. And here's how I want you to do it. there is a file at the top of this repository called I can edit this repo.txt. And this lists all of you, and all of you by your initials. So what I'd like you to do is, if you haven't done it already, it looks like four people have. Awesome, thank you very much. Go open up this file. Replace your initials with the word here, and it's like we're taking attendance, and we kind of are in a way, and then commit and push that change up to GitHub. Let's see. I think we've got almost everybody here tonight. So far, has anyone encountered issues with getting a clone of the repository, or editing that file? Okay, I think I see that a couple of folks here who are in class also have their initials still in the file. Okay, in Zoom, please react with some reaction indicating whether you have already already changed your initials or are in the process of changing them. I want to make sure that there isn't anybody who's stuck.
I'm in the process, but I don't think I'm a contributor, so I can't actually push.
Oh, really? Let's fix that then, because the intent is that you should be. So if you don't mind, let me go to collaborators and teams. I thought I made everybody, sorry,
Uh,
who was
no, pending. Oh, I didn't. Yeah.
Yep. Yeah. Sorry. Okay. Right. Yeah. There should be. Please check and it looks like maybe is that Yasmin? Yeah. You might have one also, Yasmin, and pending. Oh, that's their old one, isn't it? Yep. Okay. So yep. So yeah, Trevor. I think that's it. Just look for your email for an invitation from me to be a collaborator. Thank you to everybody who accepted it. And so then I think then see how we're doing. Nice. Okay. Good. Thanks. As folks who contributed in chat. Okay. We'll check up back on this in a minute. I do want to say a couple more words about what we're doing here. Again, this is this is just a test to make sure that everybody can push because we'll all be collaborating to this repository in really all of our pairing, our pairing sessions in the when we do the refactoring kata, and of course in the mobbing sessions also later in the course. So it was a nice fundamental thing. Thanks for so many people who prepped beforehand. So I want to say a few words about pair programming just to set the stage for what we're doing tonight. Um, if you want the gory details, we do have a lecture and a screencast all about pairing. Actually, the lecture itself is in two parts, it's both the pairing and the mobbing. You can watch the mobbing later. Um, So, pair programming, really came of age when test-driven development did, when people were writing lots of software and really discovering, or maybe in the case, rediscovering what it means to build software as a team. And so in pairing, you have two people who are sitting at the same keyboard and working on the same problem at the same time. And this is really in stark contrast into sort of a more asynchronous way of development where one person works on their own and maybe gives it to someone else for feedback or shares it. There's some nice pluses for pair programming. Um, by getting two people, two brains on the problem, it really helps identify what a high quality solution looks like faster. And as we'll talk about, by adopting some simple roles and taking on a couple of straightforward roles, it's a good way to get started with pairing, and so that you can begin having that conversation, having those effective behaviors that lead to great outcomes. So traditionally in pair programming, each member of the pair takes on a particular role that has a particular focus and set of behaviors associated with it. So one person in the pair is called the driver. The whole idea is the driver is the person whose hands are on the keyboard and who's typing. This is really the person who is writing the code and is very tactical in nature. Like, what's the next line of code I need to write? Or, hey, what is the test that, or, how do I implement the test that we're working on right now? Um, and the other person takes on the role of what's called the navigator. And the navigator is, if the driver is the hands, the navigator is the brains. The navigator is the person who, in the moment, is observing what's happening, is thinking one or two steps ahead, and is really driving the conversation with the driver. A clear anti-pattern in pair programming is silence. The idea here is that the ideas need to go from like brain to keyboard through somebody's mouth. And this is where you really get the pairing. And this is the impacts of pairing. And this is how you can really amplify the capabilities of each member and come up with something that no one person would do on their own. So the navigator is more strategic and the driver is more thinks more tactically. While it's good to have these roles, it's also very effective to switch the roles. That avoids burnout, it keeps people from being bored, and then also gives each person an opportunity to understand the role, develop muscles, practice both being the person that types and the person that dreams, that thinks up things. And so then every couple of minutes, the pair trades roles, and this helps offer different perspectives and keep people fresh. Now, after sort of at the end of the pairing time before you switch roles, it's good to take a moment or two and just reflect on what you saw. This built-in retrospection aids learning, gives a natural rhythm to it, and helps you identify better ways of doing things very rapidly. And so then we'll be doing that tonight. So after a 7-minute round of coding, we'll actually I have these little cards here that have good prompting questions for the retrospective that we'll just spend like literally a minute or two discussing. And once you've talked about what happened, maybe made some, gotten some ideas for next time in terms of, how you work, then time for the roles to switch, and the new driver will pick up where the previous driver left off, and go from there. Now, you'll learn a lot about, interpersonal dynamics and all of this. And as we'll see in the cheesy little video, we have, there are some anti-patterns, and one of them is when you become the driver to just like rewrite everything from scratch the way you would do it. While that might seem right, it's not necessarily an effective way to have two people who understand and feel they have contributed to the understand the problem and they contribute equally to the solution. So, instead of using your fingers right away, use your mouth and talk about the situation, talk about where the code is deficient, and then how it might be improved and refactored together. I go into lots more details in the lecture, but I did want to call out a couple of patterns that have been effective for pair programming. One is called strong style pairing, And this is good when you've got two people whose experiences or skills might be mismatched. You might find that tonight. It's good for knowledge transfer. We've got someone who's more of maybe a mentor or someone who's very experienced in the code base, paired with someone who is less experienced. This is a good situation to be in, because it really sort of makes the distinctions clear, and it helps the person who is less experienced to learn new things, and it helps the person who's more experienced see things from a beginner's perspective. So then, what things are awkward, what things are maybe you think are hard or actually easy to understand, things like that. But just, be careful that you don't have a dynamic where as one person watches someone else code. That really is a conversation along the way. And that takes discipline on both the navigator and the driver. And so then, it also, reinforces, concepts like, in order for an idea to go from the navigator's head to the driver's hands, it must go, out somebody's mouth into somebody's ears. So again, this is very deliberate. This helps us learn. This is how our brains have evolved to work. And it's a really great way of taking everybody's abilities and perspectives, and then creating something awesome. There's also a style of pairing called ping pong pairing, which really is nicely paired with test-driven development. So the whole idea is you have one person who writes a test, and then it ping pongs over to the other person to make it pass, and they go back and forth of writing tests and and writing implementation. We might want to experiment with this tonight because we certainly will be doing test-driven development. We'll see how it works. So anyway, here are some references, excuse me, that I found to be helpful with pair programming. I encourage you to check them out. As a matter of fact, we will listen to this one right here. Oh, I want just to share a little differently. Actually, can I share? Can I say share settings? Can I advanced settings, auto screen mode? Oh, okay. I thought I could enable sharing the audio from there. I cannot, so I'll just stop and reshare. So now I want to share like I said, a cheesy little video that actually does a good job for introducing pair programming.
Now you can use your points
Oh,
to
you're
get
kidding me.
dollars off
Fred Meyer
groceries or saving at the
commercial.
pump. Redeem your points today.
Could you guys hear that okay?
Yeah,
Is
I
the
could
audio-
hear the ad.
The audio, okay, yeah, I apologize for all that. Now you know what's on your list today. Anyway, so this is it's cheesy, it might be a little dated, but it's a fun video about pair programming for students.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
why do so many thousands of students around the world prefer pair programming? Why don't we ask some? to compare old-fashioned solo programming to this new and innovative system.
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Oh, super easy. Oops. Oh, did I just close the browser? Yeah, I think I did. Dumb. Oh, no, it's just full screen mode. That's why. Okay. Well, so watching that video, what are some of your initial thoughts on pair programming? Anything that stands out to you as surprising? Anything that excites you, makes you skeptical, that you wonder about? Now that you've watched that video and heard a little bit more about pair programming. Nice. Okay, a couple things here in chat can help you be less likely to get stuck on a single bug for 2 hours. Yes. Yeah, I think that's been my experience too, is that you tend to get stuck. Yeah, definitely less often, but certainly for less time. Um, yeah, conflict resolution, checking egos at the door. Yeah, it really is, an exercise in not so much getting along with other people, but I think the skill that I've had to develop is being able to express what's in my head in words, and not just like, resisting the urge to grab the keyboard and show how I think it's done. Yeah, take critical feedback, communication. Yeah, great, great, great. And it's interesting. It's this nice way to develop both the technical skills and the behavioral skills that are necessary to be an effective software developer. Great stuff. Okay. So, as I mentioned, we'll be using a GitHub repository to share our code. And not only to share our code, but also to share our code with each other as part of pairing. The first few times I did this, the department had actually gone out and bought me like these USB keyboards, which I thought would like work well and stuff, and it ended up being kind of a mess because it's different from everybody else's keyboard. And I it, gone are the days where anybody feels comfortable with having someone else touch their keyboard on their laptop and stuff. So instead, what we do is we, share our screens either looking over each other's shoulders or using the projectors here in the room, or using Zoom to share that way. And so when it actually comes to like, you're at the end of your round and you are done with, when the driver is done with their contribution, they commit and push it up to GitHub. And this is a perfectly valid way of exchanging code while you're pairing. Just remember that, ultimately what we're here to do is to have a conversation and to, arrive at a solution together where everybody has an opportunity to be part of the decision making, be part of the ideation for coming up with a solution. So back on our GitHub repository, let's see if everybody's had an opportunity. Yes, good. Everybody's able to push. Thank you. That's a very important check here at the beginning. And so then, awesome. Looks like we are all set there. So for the pairing exercise, the mobbing exercise, and then also the refactoring exercise, which we'll do next week, we work on little programming projects called katas. So this comes from the martial arts. The idea is that you have a very small and focused exercise activity that's really meant to, work one set of muscles or develop some technique. Here we'll be developing pair programming and test-driven development. In addition to learning our tools better, like, IntelliJ and Git and things like that. And so then, these are, again, small programming problems, and the problems themselves are not the point. Like today we'll do FizzBuzz, and we'll probably see that AI will, like, as soon as we start, coding, AI will be like, oh, I know what FizzBuzz is. Well, that's great. That's great. That's great. It's a very simple problem. And it's not about solving the problem. It's about developing the skills to solve the problem. So here again, what we're learning about system development and pair programming and IntelliJ, the fact that, like, oh, look, we're, scoring a game of tennis, or we are, figuring out if it's a leap year or whatever, the problems themselves aren't terribly interesting. So, to get us started, and what tonight's activity will be is what I like to call the operating theater. So I don't know if this is actually a term that other people use, but for me, I don't know if you've ever seen, like, in the movies or a hospital TV show or whatever, where when they have a bunch of medical students and they want to learn about, well, performing some procedure, some medical procedure, they have this operating theater set up where, yep, there's an operating room there sort of in the middle, but around it there's all this viewing area. And that's a metaphor that I like for learning these kinds of things. So you'll get to see other people do it, and it'll be, your fellow students and me. And this, gives you an idea of what it looks like. And so you're here to observe and, and pay attention to some of the things I'll be asking you about, like what you saw, to get your ideas and your feedback on it. And so then we'll do the following. So I will invite all of you to pair with me tonight, and to indicate who will pair with me in which order. I ask you to go in the Kata's repository, go into the FizzBuzz directory, and there's a pom.xml in there. I'm opening it right now. Great. And so then please open that. And if you would like to pair with me, I'll call for volunteers first. Please go in here, find one of these developer slots here, and replace the student name here with your name, and then indicate whether you have to be a driver or the navigator. So I'll pause here just to give everybody a moment to go and find that file and sign up.
Some quick questions.
Yeah.
Are you fine with, like, inline chat assistance as the driver, or you just want it
For tonight, I really
Nothing.
like there to be an audible conversation. It'll be easier for everybody to follow, including myself. And that way it's, we can have like one person speaking at a time. And is that what you mean
No,
by,
I mean like an ID. You know how it has like auto finishing lines or AI suggestion.
oh, that? Oh, sorry. Yeah, sorry. I completely misunderstood. Yeah, I'm open to that. I think my IDE was, I don't know, I've got it configured to do that. I need to figure out how to turn
Yeah,
it
I
on.
think you have it like on medium or low suggestion
Probably.
frequency in your ID.
Yeah.
But that's
And
fine.
again, the goal here isn't so much to implement the to just rush to the end. It's about experience the journey along the way. Time permitting, though, I'm happy to do what I did with that bonus TDD video I recorded over the weekend, which was, hey, once we have our solution, ask AI to implement it and compare and contrast the two. But that'll sort of be bonus stuff only if we have time for it tonight. So please edit the pom.xml and commit and push. Don't have anybody yet. So while you're doing that, I'll talk about the kata itself. So actually, show of hands, how many of you have heard of the FizzBuzz kata before? I don't know if it's something that's sort of still in the. Anybody heard of FizzBuzz? Let's give you haven't. Yeah. So okay, yeah, good. Tristan's heard about it. Thanks. So looking at the nice. Looking at it, it's a very simple problem. Now, the whole idea is that, hey, imagine that you're in like an elementary school classroom, and that you're playing this game with the teacher to teach you about numbers being divisible by other numbers. And so the teacher is up there, and the teacher calls out a number, and then the class is supposed to respond accordingly. If the number that the teacher calls out is divisible by 3, then the class says buzz. Sorry, the class says fizz. If the number is divisible by 5, the class says buzz. If it's divisible by both 3 and 5, they say fizz buzz. Otherwise, they just say the number back at them. And so then, and actually, I'll post this in the chat if anyone wants to read ahead, or actually read it. Arcata. And so the whole idea is that you'll have a program that prints the numbers 1 to 100, and then every time, but if the number is divisible by 3, it does fizz. If it's divisible by 5, it does buzz. If it's divisible by both, it says fizz buzz. Otherwise, just prints out the number there. And there's a stage 2, but maybe we'll get to that later. And so then what I'd like to do to explore pair programming is to implement this all with you. And to do that, I created here in the Kata repository a FizzBuzz project that looks a lot like student or project 1. There's a FizzBuzz main class that has a FizzBuzz test unit test associated with it. And well, technically these do have command line program. So there is an integration test for the command line, but I don't think we're going to deal with the command line. We'll probably just do some unit tests that implement this very simple logic of the code kata. Let's see here. Any brave volunteers? I'll even take cowardly volunteers. Awesome, Sid. Awesome, Adam. Thank you very much. Okay, good. I encourage more people to sign up too. It just is good to get us a variety of perspectives on the problem. So what we'll do is we'll do some red-green refactoring. So we'll write a failing unit test first and FizzBuzz test. Then we will implement the production code to make it pass, and then look for opportunities to refactor. And again, the goal here isn't just rush to the end. And the goal is to explore pairing and a recurring factor and test-driven development, along the way to build muscle and build muscles for those skills while focusing on a very simple problem. So really, the implementation itself isn't that difficult. It's more about getting there. And so what we'll do is, now that we reviewed the requirements for the kata, we'll do a series of 7-minute what are called pomodoros, which is basically a time-boxed, focused activity. And so then we'll have our volunteers pair with me for 5 minutes as either the driver or the navigator. So we'll implement, I don't know, 1 or 2 tests in that time. Then we'll take a moment when we take 2 minutes to reflect on the experience and then move on to the next volunteer. And so then, at the end of the Pomodoro, who's ever driving will commit and push their code to GitHub and then have the new pair pull it down. So the new driver will pull it down. And then we'll go from there. And then I don't know, probably every 3 or so Pomodoros will open it up for a larger discussion, a larger retrospective to hear from what the people who aren't part of the pair are observing. So that's our activity. That'll take us I don't know, 45 minutes or so. Anything that folks would like to discuss though before we dive in?
Have we established our code formatting expectations? Just follow as
We'll figure that out
closely.
along the way. That's a great question, Adam. Yeah. Well, and speaking of which, let's see here. You signed up to be the first student and as a navigator. That's awesome. So then, shall we start then, Adam?
I can't remember which role is the one who's actually doing the coding.
That is
But
the
I
driver.
prefer. Okay, that's
What would you like to? What role would you like to
Yep.
be?
Works for me.
You have to be the navigator, meaning that. Oh, actually, wait a second. I'm going to reshare the screen because I'm sharing video still. I don't need to do that.
Yeah, I can be the navigator.
Okay, sounds good then. Let's see here. Don't share sound, don't optimize for video sharing. Cool. Good. Now things look a little better. Okay, I'm just going to get your face up here on screen. Thanks for coming off video. That'll help interact. Okay, so then I'll be the driver then. And so then I will drive. I'm going to put 5 minutes on the timer here. And we'll start. Okay, Adam, where would you like me to start?
I think we should start first with a divisible by 5 function, a test.
Okay.
So this function should call, is this number divisible by 5? Probably return a Boolean. And so the test should call this function with a number that's not divisible by 5. Also a number divisible by 5.
Okay. So let's see here. We'll
And
start
then
with
an
number.
error
What number would you want to start with?
5.
5. Okay. Okay. So
And
then,
then assert equals.
yeah. And then I'm going to use the ham crest if that's all right with you. Okay. And then let's see here. We want some method on FizzBuzz. FizzBuzz. Just call it is divisible by 5.
I think that's clear enough.
Yeah. Number, and we want
And
this to
it
be
should return a Boolean.
nice.
Or we could, I have a question. Would you prefer Boolean or something like -101, where the -1 could return an error? Or do you want to throw the errors in the function itself?
That's a good question. I mean, are there any particular I guess the thing I would use to figure out the answer to that question is what test would I write that would generate an error?
If you wanted to throw a non-numeric into the arguments.
Well, right now it's an int. So I don't know if we could write that test, right? So like what number would we pass in here that would generate an error code?
Or a float. We haven't decided what the data type is for is divisible by 5, whether it's
Oh,
going
that's a
to
good
take
point.
a
I was
text or a
assuming.
number or
Well,
something
yeah,
else.
and so then I was assuming it would be a number, but should be a string instead.
If we decide it's a number, we're gonna have to. It, I'm pretty sure the Java compiler will throw an error if you're trying to not feed the data type. But if you
Yes.
want to ingest the command line, I guess you want this function to be ingesting command line arguments. I think we should keep separation of duties
Hmm.
for TDD and just leave it as a number.
Good.
And the command line arguments can be parsed before drawing them to these functions.
Nice. Okay, so I had IntelliJ create that method for me. Is equals by 5, and it returns false. So I think if I run this, I should see it fail. Always a good thing. Yep, nice. Now, how do you want to implement this method?
I think we should do it the fastest way possible, which is either checking the rightmost digit on the number, or or you could just do the easy way of the modules. You
Let's
could
do the
use
module.
modulus operation or
Good.
the fastest way, which is checking the
Yeah, does that look
rightmost
right?
number.
Yeah, I think if we do mod 5, it should equal 0. Let's find out. Nice. Okay, well, that was easy.
Would you like to continue?
Yeah, let's keep doing it. We got another, I don't know, a couple minutes. Yeah, 1 minute, 16 seconds. Like, what's the next one to write?
Is not divisible by 5.
Ooh, I like that. Okay. And do you have a particular number?
13.
Okay. Let's run this. I think this
I
one
like prime
passes, right?
numbers.
Yeah, that one passes. That's good too.
Now, what happens what kind of error do we get thrown if we pass something that's not a number to
Well,
is divisible by
specifically,
5?
yeah. What would you like to pass?
Just do a text argument like experiment, and we
Okay.
can see what the error
So
is.
this would be
So
like, oops.
I don't know if you're gonna have to do a try block for this or not.
Well, see, this isn't compiling yet because this is a string. So then this needs to be a string. And then this doesn't compile because it expects an int, but I'm giving it a string.
That won't be a problem then.
Yeah, I think we don't need to worry about this particular case. Now, and actually, that's a good point. I don't know if, I guess we can really talk about the end result here, but I don't know if we're ever gonna, yeah, if we actually do convert strings to numbers in this particular scenario. But that is the end of our, oops, that is the end of our round. That was cool. Now I'm gonna draw a card here. Let's see here. Oh, I don't know. Let's see here. There you go. What challenges did we face, and how can we overcome them in the future? So, Adam, I'll ask you. I mean, was there anything challenging about this for you?
Well, you wanted to go with the modulus. What was the easiest way to implement is divisible by 5? But I was interested in going with the fastest way. So I guess it would have been nice to consider what the application is for the program and decide whether this is speed is necessary or readability in the
Excellent.
design constraints.
Yeah. Let's see here. For my part, oh, I should have set a timer. Well, whatever. For my part, actually, I didn't find things too challenging. I do appreciate, again, you being on camera. It's easier for me to, look at you so I can tell when you're talking or when you're about to talk. And then, yeah, I think we chose a good place to start and wrote some simple unit tests here. Good stuff. Thanks, Adam. Appreciate you volunteering to be first. I am going to commit these changes up. Begin FizzBuzz. Oops. Buzz Kata. Well, let's see if that gets rejected or not. Nope. Which means that no one else volunteered. So thanks, Adam. I guess Sid, you were the next volunteer. Oh yeah, Trevor's up there too. Excellent. So Sid, let's hear. You'd like to navigate. Okay, good. Have me type again. Sid, would you mind coming off mute and make sure we do a quick mic check here? Oops, did we lose Sid? Okay. No, we are Sidless. Okay, no problem then. Trevor, let's see here. Thanks for joining. How about we go to you next? Sorry, I'll come off mute. Thanks. Oh, could you say something just to make sure we can hear you?
Can you hear me now?
Excellent. Good, good, good. Oh, hey, thanks for coming off camera too, or coming on camera. Yeah, let me just start the timer here. So, you were watching what Adam and I were doing. Where did it go next as the navigator?
Yeah, so I guess the struggle for me is the test-driven part because in my head, the first thing I would do wouldn't be in the test. It would be to probably do a for loop from 0 to 100. But if we're trying to do test-driven, um, I guess we can basically replicate the divisible by 5, but do it for the divisible by 3.
Okay.
Um,
Nice. Yeah, I can do that. I'm just going to do that. I think the easy way is by duplicating this code and then changing 5 to 3. And let's see here. Oh, this will be divisible by 3. And then do the same thing.
and
3.
then I
Yeah.
guess I'm just wondering, because the test is supposed to determine things we do and don't want, but we don't actually not want numbers that aren't divisible by some certain thing. We just need to know that we're going to put BuzzFizz in. So I guess is the not divisibles, are those necessary? That's what I'm trying to understand. Like the not divisible by 5 and not
No,
divisible by
no. I
3.
mean, because, yeah, I mean, are we going to pass a number like 4 to this method?
Yeah, yes. So our
So, yeah, maybe we do then. We need to make sure. I mean, so like, for instance, yeah, 4, then that should be equal to false.
okay. Man, test driven confuses me. Um,
Yeah, it kind of is just, yeah, knowing where to start. But I like what you were saying before, um, about how, like, hey, you know what the code that you want to write. So maybe want to just like quick bang this out. I mean, so this is going to be numbered as right. We think this is the right thing. And this one was super easy, I think, because we'd already done it for 5. But now that we've got these two parts, like, yeah, you said, hey, listen, ultimately what we want to do is go 1 to 100. And do what exactly? So, like, if there was, I mean, just sort of talking here, like, if we were to have the 4I equals, 1 to 100, what's inside the body there? What does it do? And is that something that we can test?
so yes. Okay. So let me think. So we're looping through. We can use I as whatever we're
Mhm.
uh evaluating for BuzzFizz, and then I would just go through each function is divide or divisible by 5 or 3, and then uh
Yeah.
print. Otherwise, just printing a new line. But that's where I struggle is when we're is how to turn these into tests.
Yeah, I mean, and it sounds like it sounds like we've got this, like, we've got inputs and outputs, right? So the input is a number, and then the output is fizz or buzz. And when I hear inputs and outputs, I think a method, I think a function. So
Yes.
maybe that's a function that we can test. So something like, fizz buzz of 1 is 1. Yeah, and then so here it kind of speaks to the need for another function. I would call it just like FizzBuzz. And then this would just be the string 1. Because we want the output to be so FizzBuzz, like you pass in the number and it returns the thing. Actually, maybe we should start with FizzBuzz of 3 is fizz. Maybe that's a better way to start this. So FizzBuzz of 3 is meant to be fizz. Get what I'm saying here? Right? Because to me, it's like this FizzBuzz method, which is the thing that's called inside the loop.
Hmm.
So yeah, let's create this. And then, so another test room development thing, like what is the minimum code that we should put here to get this test to pass? And remember that the test is just FizzBuzz of 3 is fizz.
Um, just return 3.
Like this?
Oh my gosh, this is um no, and it's an integer return uh fizz.
Yeah. Oops. Let's see what that did. Let's run this, and we are out of time. Nice, that passed though. I guess we should have seen it fail first, but good, good, good. That isn't too surprising then. Nice. Thanks, Trevor. Um, so yeah, here's a good question. What did I learn from working together? So what did you learn in our 5 minutes of pairing?
When I'm struggling with the concept, I can bounce it off my partner to get a different perspective.
Yeah, and I think I learned the value of like taking your instinct, running with it a little bit, but still in the context of like, oh, how can we extract the test? And I think that's when it sort of became clear to me, where it's like, oh, right, I agree. Ultimately, we're going to want a for loop, but like, what does that for loop do? Oh, that's the thing that we can test because that's the thing that has the input and the output. Nice, nice, Trevor.
Cool.
I will commit this. Let's see here. Implement more FizzBuzz. These are not good comments. Okay, let's see here. Is Sid back? Nope, looks like we lost him. Anybody else would like to go before I start calling on people? Thanks, Ella. Yeah, that'd be great. And you want to be a navigator? Yeah. So let's do it. Yeah, please come off mute and yeah, we can continue working on this. You've had an opportunity to see a couple other people approach it. Where do you want to take it next?
Can you hear me all right?
Yeah, you sound great. Thanks for checking.
Okay, awesome. Kind of something that stood out to me was since you already did the test for FizzBuzz of 3 is fizz, maybe we could write a test for FizzBuzz of 5 is buzz.
Yeah, that's smart.
And then it would kind of be the same thing, just changing it to 5. Yeah. And then to buzz.
Thanks. Okay. So yeah, let's run it here. Okay. And it fails, not surprisingly. So what should we do to make it pass?
Well, let's see here. We would return buzz instead of fizz.
Okay. So here, I'll run it again. Nice. It's got buzz. And so like we got one test pass. Let's see what all of our tests. Let's run all of our tests. And now the FizzBuzz of 3 fails because when the number is 3, it returns buzz instead of fizz.
So in that case, maybe it would be better to have 2 separate functions.
Well, I think the
Maybe
intent, yeah. And my understanding of the intent of this method is that it takes any number and returns whatever the appropriate FizzBuzz value of it is.
in that case, could we do like an if else statement, like to
I
check
think,
the
yeah, I think that
number?
makes total sense. Yeah. What do you recommend?
So maybe we would do like if the number is 3, then we'd return fizz, and if it's
Yeah.
5, we would return buzz.
Oops.
And then otherwise, we would just return the number.
Oh, good. So that's probably the right thing to do. We don't have a test for that though. So, if I could like blow my little test-driven development coach whistle thing, I say, well, probably what we want though is to say, otherwise, let's just throw a new unsupported operation exception and say, can't handle number like that. Because that way, I mean, I think this will actually make everything pass. That seems good. Nice. Okay. And
Awesome.
yeah.
So, just like a clarifying question. So in this case, we wouldn't do the else because we're not testing that yet,
You have a
right?
test for it. Yeah. Yeah. But do you want to write that test next?
Yeah, I think that's a good idea.
Nice. What would that
So,
test look like?
I think it would be like we could name it something like FizzBuzz. Um, let's see here. Like not 3 or 5 is number string, something
Okay.
like that.
Yeah. Or actually, how about let's just use the number. What number do you want to put through this? That isn't 3 or 5.
Maybe like 10.
Okay. And so
Oh
number
wait, sorry. That might
by
actually,
5.
yeah, because that's divisible by five, maybe 4.
Okay.
And then we would put 4, and then it would be equal to the string 4.
Nice. Yeah. So we'll run this. Yep. There you go. Unsupported operation exception can't handle number 4. And so then, okay, now we want to support it. What do you want to return here? Excuse me.
In this case, do you think it would be better to return the number itself, or would we return 4 since we're testing that?
Oh, good question. Um,
Either way, it would return that. Well,
yeah,
I guess, sorry, if we're returning number, it would actually return an int, and we want to return
right.
a
We'd have to
string.
do that. Yeah. Well, I mean, I think if he's a little pedantic, but we could use a number like we could write another number. We could write another test for like 6, and then because it'll make that one pass. But then if we did something like 6 for like then this is I think what would force us to implement the conversion of the number to the string. Oops. Yeah, 6 fails because it always returns 4. So yeah. So I think here, yeah. So how do we return the string value of the number that's passed in?
I can't remember how you cast an integer to a string in Java, but you would cast it and then just return that value. I don't remember the syntax for it though.
Yeah, and actually in Java, it's technically not a casting operation because an int will never be a string. It's more of a conversion thing. So there's a couple ways you can do it. You can concatenate it to an empty string. I'm surprised IntelliJ doesn't yell at me for doing that. I think the way that I prefer to do it is I say string.value of, and that will take, an int or, a number or an object and convert it to a string. So yeah, it's more of a data conversion operation than it is a casting operation because again, a number is not a string. But yeah, let's give that a chance. Nice. That's good. And that was time. Excellent. So let's see here. Here's one. Did we all feel comfortable sharing our ideas and perspectives? Yeah, what was your level of comfort here, Ala?
Um, I was comfortable sharing my perspective, but there were like a couple things that I wasn't sure of how to like communicate. But I think it was really helpful, especially with you kind of explaining some of like how to write the tests and also like the string portion as well. That was really helpful, but I felt pretty comfortable sharing like my thoughts.
Great, thanks. Yeah, yeah, and so did I. I appreciate you being open to, maybe trying something and see if it works, and sort of, trying to triangulate the solution. I acknowledge we're going in pretty small steps here, but no, so I appreciate you being open to it, to listening, but I'm also kind of aware of the power dynamic here, right? Where it's like, okay, there are things that I know, that that you're just still learning. Great. Thanks. Okay, I will commit this in and then look for one more volunteer. Would anyone else like to go? I think we probably got one more round in us. I think we're almost done here. Or do you think we're done? Are there other things? And there's a question for anybody, whether you've done or not. Is there more that we got to do in this kata, or do we think we're done?
It's definitely not done. Could you hear me okay?
Yeah. Yep, you were a little soft at first, but you're hearing okay now? Yeah.
I guess I can volunteer. I don't know.
Thanks. Yeah.
Yeah. I was just looking at, well, because right now the FizzBuzz function only tests for 3 and 5, so we want to be able to test for anything else.
Yeah, nice. What would you recommend testing for?
Well, I guess I'm like Trevor, where the test-driven development isn't always like my strong suit, but I mean, at least in the actual code, we have those two methods, I guess they're called in Java, that is divisible by 5 and is divisible by 3. So we would want to use those. And then instead of doing if number equals 3, do if is divisible by 3 number. And then same with the number equals 5.
So how would you make sure that that was implemented correctly? How would you know?
Well, we have the test. Can I check out the test again? What do we have?
Yeah.
FizzBuzz of 5 is buzz. Okay, perfect. Of 3 is fizz. So, I mean, do we not already have the tests that we need to check that? We've got the.
Wait a second, we did 6. This test is wrong, isn't it?
Yeah, 6 would be. Yeah, that would be.
Yeah.
Fizz or buzz. I forget. Is fizz 5?
Buzz is 5.
Okay.
Fizz
So
is
then
3. I know, I always forget too.
So
So okay,
FizzBuzz
yeah, we
6
should
be
fix
fizz.
this. So let's see here. We did 4. Maybe if we did 7. Yeah, 7
Yep.
instead. Okay, so I changed this. This one I think it'll still pass. Yeah. Okay, so now we need to do 6, implement correctly, and 6 should be fizz.
Mhm.
You know what? I can't tell you how many times I've made the same mistake where the bug wasn't in the code, it was in the test. It was testing something that I didn't realize that I was testing. So again, and then this is 6 should be fizz. And here, if I run this one, yeah, that
So
fails.
that's failing.
Okay, so what should we do to
Because
fix
we
it?
haven't implemented those tests yet. So
Yeah.
I guess we could do that for a multiple of 5 as well. We could do FizzBuzz of 10 is buzz.
Yeah, let's keep that one. Let's get this one. Let's take
Okay.
this one from
Let's do
red
this
to
one.
green, and then that's probably the next one we should do. Yeah.
Yeah.
So what we got to do to turn this one green?
Just take out the number equals 3 part and then do is divisible by 3 number.
Oops. By 3. Nice. It's running all of them. Oh no, it's not running all of them. Okay, we're going to run all the tests. Nice. That all passed. Cool. Okay, now you want to do another one. What was it? What was it again?
FizzBuzz of 10 is buzz.
Nice. Yep, fails. Okay. Now, same thing here.
Yep, same thing in there.
Got it right this time with 5. Okay. So let's run all of them. All right. Good. That one passed. Let me do all of them. Yep, all of them passed. Okay, cool. Anything else?
Not that I can think of. I mean, unless we're dealing with like negative numbers or I don't know how input is. Okay, so it's going from 1 up to 100.
Yeah. Oh, right. There's the FizzBuzz, which is like if it's a multiple of both 3 and
Oh,
5.
okay.
Yeah.
Yeah, we could implement that.
Cool. What
So
would the
yeah,
test be?
just do FizzBuzz of 15 is FizzBuzz.
Gotcha. Yep. I see here. Expected fizz, buzz, but was fizz.
Mhm.
Okay. What we gotta do to fix this?
Let's see. Well, I want to get fancy with it. I want to do like nested ifs, but we don't really need to do all that. But I don't, well, okay, so I think for the first if we should make that an else if and then have a like a primary if, like change out that, like have the primary if be if is divisible by 3 and is divisible by 5.
Great.
And then return FizzBuzz.
Okay, yeah, let's give that a try. Nice.
I guess we could also have an is divisible by 15 and just do that, but that's okay.
Yeah,
Works
right.
just as
Yeah,
well.
does that really help us in that case? But good thing about refactoring though, yeah.
Mhm.
Well, nice. Okay. That's the end of time, but I don't know, is there anything else that we need to do on this one? So I think we might be done.
Yeah, I can't think of
Well, or
anything.
maybe not. Yeah.
Unless you wrote a fancy unit test with a for loop and try
Well,
to
and there we could write an integration test maybe. But okay, so maybe there's a little bit more. Let's we'll call for one more volunteer. But first, let's do a retrospective. Let's see here. I guess I like this one. Did we leverage each other's strengths and knowledge effectively?
uh I would think so. I mean, you're the professor, so I tend to try and leverage that. Yeah, I would say so on my side.
Yeah, but I really liked your ideas. I thought you communicated what you wanted to do very effectively, and appreciate you being open to like writing the test first. Because hey, once we figured out we needed to do FizzBuzz, you knew exactly what test to write.
Right.
This is learning the TDD, right? Where sometimes it just takes a couple of examples, then you figure out the pattern, or you're like, okay, yeah, this is what I want to bring into reality. Write the test for it first, and then it's pretty straightforward to figure out what you need to do to make that happen.
Mhm.
Nice. Okay. Let's see here. I think we got one more where what we could do is we could write a main method that goes through and does the looping, and then we could have an integration test that tests the output if you want. I don't know. What do y'all think? Anybody want to see if we can bang that out in a pair? Yeah? Adam? Okay. Yeah, okay. Who wants to volunteer to be a pair? Pair with me on this one. Saw some thumbs go down.
I can do it.
Trevor, awesome. Thanks. Yeah, yeah, yeah. Okay. Well, let's see here. So then, yeah, the whole idea is that we have a main method that prints 1 to 100. Like how to test that? What do you want to do to test that
Um, I
integration?
had an idea. One second.
Yeah.
So we can let me look at what we already have.
Hmm.
I feel like I had an idea and I completely just lost it.
Yeah, I mean, with so much like, I mean, 100 lines of output, that's really hard to.
Yeah, so we just do a for loop or yeah.
Yeah, okay. Well, yeah, maybe we don't need to write an automated test for this. We could just try it from the command line. So what would the for loop look like?
Int I equals 0. Or do we want to start at 0?
No, I guess we go start at one, don't we? Because I think
1.
it starts at one. Yeah.
So I equals 1, I is less than are we doing up to 99 or 100?
I think 100, 1 to 100.
So less than or equal to 100 plus plus I or I plus plus.
What did I get wrong here? Or oh, I need a variable anyway, that's why. Okay.
Uh, and then buzz fizz I or fizz buzz
Okay.
equal or I equal, oh no, not I equals, just yeah, fizz buzz.
Nice. Oh, thanks, AI. Seems reasonable. Let's see what we get there.
Oh, I can't see.
Yeah, I scroll pretty fast. There you go. Printing it. 1, 2, fizz, 4, fizz.
Broken. Wait, no, that's still good. Never mind.
It's fizz. Yeah, I know, right? Yeah.
Okay, yeah, it's good.
11, 12, 13, 14, 15. Well, it's pretty good. Well, so now we have this. It's pretty easy to implement. I don't know. I think it's going to break this test because it's no longer printing out missing arguments because it doesn't have any arguments to print out. What would we, I don't know, is there a test that we can write that'll pass easily? Got an idea. So if we run the main and let's say that we have string output equals result dot get straight and ready to standard output. And then I don't know, we can just say something like assert that output contains string. I don't know, we'll just do like the first 10 lines or something. That's probably not too ugly in a oops, where's the running? Yeah, I'll start from the command line. FizzBuzz. I gotta build it. Oops. Yeah, so what I'm going to do here is let's try it from the command line. Maven W, where's the jar file? It's a java-jar target FizzBuzz jar. I just got all this stuff. I don't know, we'll say the first 10 lines of it here. And if we just paste it over here, I wonder how ugly it's going to look. Not so bad. Oh, wait, why is it complaining about their concatenation with text block? Oh, yeah, let's do that. That's neat. Okay, yeah, let's run this. See if it passes now. It does. So, I mean, that's like, it's not all 100 lines, but I think this sort of like tells us that it's good enough. Yeah. So, I mean, I think it's a sufficient unit test or a sufficient integration test. That's, I guess kind of interesting lesson about like how much we should do there. Neat. Okay. What do you think, Trevor?
I think we did it, except for this integration test doesn't care about FizzBuzz.
Oh, you mean it doesn't get all the way down to 15?
Yeah. Other than
Yeah,
that,
it's a very good point. Let's add it. Let's add it. Let's just go all the way to 16. Let's see here. Oops, it doesn't exactly get it right. So let's see if I can fix that. Oh, there you go. That looks better. Yep, still works. Nice. Okay, let's I want to do a Maven clean verify just to make sure. Maven W clean verify. Nice. Okay, that all worked. Trevor, anything else you want to do before we commit it and push it?
I'm happy with it.
Let's do it. Yeah. Nice. Implement a main method that prints out FizzBuzz from 1 to 100. Sweet. Okay. Yeah, I like that. Well, nice. Let's do a quick reflection, and then I want to open up to everybody to talk about what they saw tonight. Um, Here's one. How can I better prepare myself for future coding sessions? I don't know,
Uh,
Trevor, any ideas like
Practice test driven coding.
it is a different approach. I think for me, well, I mean, it's tough. I've done this kind of like a zillion times, so it's like I have some ideas of like how I would do it. I think just in general, and it's something that we really didn't do tonight. It's something that we'll do on Wednesday though, which is begin with a round of just brainstorming the problem, understanding what kind of solutions, identifying key test cases. That's an adaptation that we made a couple of years back with the pairing, and that really helped. So that's something I'll definitely keep in mind for Wednesday. Nice. Thanks for volunteering, Trevor. Well, so now I'd like to open the floor to everybody for just a quick, 3, 4, 5 minutes about what you saw in this operating theater exercise. So, almost everybody had an opportunity to, or took the opportunity to be part of the pair, and then you all got to watch the other people pairing. Just what are some of the things that you observed?
One thing is it's kind of hard to really be challenged with conflict resolution in these scenarios because it's low stakes. In the industry, things can be high stakes because making design decisions or architecture decisions, you have to maintain that. And I have seen some people get really spicy about design decisions. And I don't think we'll ever get to that point in this class because you don't want to be maintaining something that then becomes a nightmare later. So sometimes that
Yep.
can be lead to a lot more debating.
Yep. Yeah, yeah.
Well,
Good observation there. I think by the time when we get to the probably the second mobbing exercise, there will be some design decisions, or there will be some things where you sort of get a couple rounds in and realize, oh wow, because we made the decision back there, things are a little harder right now. And no, that's okay. And that's like good learning, I think. So then don't stress, but what I encourage you to do is like if there's a decision, write down, sort of capture reminders for yourself. Like, oh, here's why we made this decision, or hey, we had these three options, we chose this one, and here's why. Just so that if you have to go back and revisit it, it'll save you a little bit of time remembering things. Great, thanks.
I did
Other
have one
people's
more
thoughts? I'm sorry. Yeah.
question. Sometimes companies really limit the amount of developer autonomy and let these design decisions usually go to like the architect. How much do they do that at your work, or how much have you seen versus developer
Yeah,
freedom
I
for implementation? Like in this paragraph programming, for example, your ticket might be really highly pre-prescribed when it's given to you compared to
Yeah, I have found that that kind of pre-planning usually isn't worth it. And of course, now with AI coding assistance, all that's been flipped on its head. So, the model of like, oh, look, you've got someone that's like, all smart and everything like that, and they just like send some instructions off to someone else to implement. Um, I think it's always been silly. So I mean, like if it's so easy to implement, why are we, can't we have the person that is that architect also go and implement it? I haven't had good experience, good success with isolated architects. I've seen too many products where their architecture looks great on a whiteboard. Oh, look, all the boxes and arrows are just nice and straight and they're all flowing to each other. And then by the time you get it implemented, it's like, oh, look, there's a bunch of latency in the system, or there are a bunch of race conditions in that system, or it's like, oh, there's a huge bottleneck there. And again, because too much was architected up front. I mean, my preference is to have emergent architecture where you focus first on understanding the problem that needs to be solved and getting agreement on what that problem is and then how to demonstrate how it's solved. Test-driven development, right? So you start out with like, here's the end in mind, here's the solution that we want, and then you start with functional validation, and then you get to validation at scale. So if you're worried about, hey, is this something that's going to handle, X number of transactions, millions of transactions? First, you got to ask yourself, well, is that a day one problem? Is it a day 10 problem, day 100, day 1,000, day 10,000 problem? Um, and if not, how many days then do you want to wait before anybody can give you feedback on it, by architecting some grand and wonderful solution to a problem that you don't even know if it's the right one yet. So yeah, so I think really what I'm seeing like today is more of an up leveling where everybody's an architect and you just have the AI coding agents write the code for you. Well, that's great, but you still have the same problem that you did before, where how do you know that the solution is the right one for all the characteristics of it, whether that be functionality, whether it be behavior at scale, whether it's resource utilization, all that kind of stuff. And yeah, that's what so gone are the days where it's just like, yep, junior coder just like writing code, which never really existed anyway. I mean, we tried to do that with outsourcing and it didn't have good results because ultimately it comes a problem of communication. So then what we all need to get better at is expressing our intent in words.
Thanks.
Yep. Other thoughts people would just share? Okay. Well, cool. That was our pair programming operating theater activity. This is on Wednesday. You'll be doing this yourselves. So hope this gave you an idea of what that dynamic is like, what it means to work in these Pomodoros. They will seem short. I think we'll do slightly longer ones on Wednesday. To give you some more time to start get into the problem and stuff. But what we're experiencing, what we're learning about is how to work in these small chunks, do a little reflection afterwards, and then flip the roles and continue on. Well, we've been going for let's see here, straight up 90 minutes now. Let's take a short break. Let's come back at 7:40, so an 8-minute break. Get up and rest your walk around a little bit, rest your eyes. And then we'll talk about project 2 and talk more about the project work. Just to get everybody oriented towards that. I'll see you in a few minutes. Well, I don't think I'll have another 40 minutes of content. Let's find out. Okay. So, in the beginning of class, we focused on pair programming, preparing for tomorrow, or sorry, for next class, for Wednesday. And so we hope you got to see what pair programming is all about. Many of you got to experience it, at least with one round, getting a little bit. And so then you'll have an opportunity to do it with a fellow student in class on Wednesday. I want to now talk about the projects. So last week we talked about project 1. Oops. Last week we talked about project 1, which was breaking ground on the multi-phase project that we'll be building this term, and it's an airline application. Wait, sorry, it is an airline, right? That was this term. Yes, an airline application, and we developed, or in that project, we will develop 2 classes, airline and airline flight, and is driven by a simple command line program that takes in a bunch of arguments for creating a flight in an airline and prints it out. And as I said last week, this is just getting started, right? This is training wheels. This is really just helping you get off the ground with the project. No pun intended with a plane. To get started there, and it doesn't do a whole heck of a lot. Project 2, which I want to talk about tonight, will make that a little bit more interesting. And in particular, what it'll do is it'll add file persistence to the project by writing the contents of an airline and its flights to a text file. Okay, it was 8:20. Thanks. Don't know if we're going to need all that time. I'll try to be concise. So here for project 2, you'll take your code from project 1 and augment it so that the contents of an airline, so the airline name and its flights, are written into a text file that can then be read back in written to a text file that can be written back in from the program so that you can invoke the program multiple times to build up an airline file, an airline described in this file. So this gives you an opportunity to learn about how Java performs file I/O, and then also work with throwing and handling exceptions. So you're going to start with your code from project 1, and then you're going to add some new things to it. There's a class called TextDumper. There's actually so actually let me go look. There is we don't need Katas right now. We don't need that right now. Where is there? Here's Joy of Coding 2026. We saw a couple of these last time. So in your main, there's already a text dumper and a text parser skeleton for you to your review. The whole idea is the text dumper implements this airline dumper interface, and what it does is it takes an airline object, and writes it to a text file. So the representation is completely up to you. Part of the assignment is designing a file format that can be written by the program and then read back into the program. And the thing that reads it back in is something called a text parser. This implements an interface called airline parser that then reads the file and from it creates an airline object containing flights. The project is driven by a project 2 class, which is what contains the main method. And what it does is it will, basically the command line arguments are all the same, and then there's a new option called -text file. And if -text file is present, then what it will do is it'll read in the contents of the text file if it exists. If it doesn't exist, that's fine. It just starts over with a new airline with 0 flights in it. And it will add a new flight to the airline as specified on the command line. And again, all the other options are the same though. -print and -readme should have the same behaviors. And that the dates and the time again are specified as 2 command line arguments, one for the date, the other one for the time, and the time is in 24-hour time. A couple of notes about the behavior of project 2. As I said, if the text file doesn't exist yet, that's okay. So don't issue an error if the text file doesn't exist. Otherwise, your program's never going off the ground. Just got to know how to create a text file the first time, and so then if it doesn't exist, that's cool. So if it's launched with a -text file with a file that doesn't exist yet, great. Start a brand new airline, add the flight, and then write the contents out. Question, as you say text file, can it live there as a JSON? JSON, yes, can be text. Yes, the only real requirement that I have for the text file is that it should be possible for the grader, who's going to be me this term. So I've got to be able to confidently determine that when a new flight is added in the program, that is persistent to the text file. So if you use JSON format, great. If you use a text file, a text format of your choosing, great. If you use XML, great. If it's binary, nope, not great. You'll lose points for that. Note also that the text file provided the program can be any valid file path. So it could be an absolute file path from the rooted file directory. It could be relative. It could be a file that's in the current working directory. Do not do any validation on the name of the file or the file path that's passed into the program. So for instance, don't validate that the file must end in .txt, or don't bother trying to validate that it doesn't contain Unicode characters or something like that. Just take however it's provided in and use that as the name of the file. And again, dates and times look just like they did in the first assignment. So as always, exit gracefully with user-friendly error message. So something that clearly conveys what went wrong and what you might want to do about it. under all reasonable error conditions. So like if command line is missing something or there's something extra, date or time format's incorrect, the text file is malformed, right? So just don't like, throw some, random exception, no print out a nice error message. And also it's an error if the name of the airline on the command line differs from the one that is in the text file. We'll talk about submitting here shortly. But we'll talk about resources before that. But I know I walked through things pretty quick though. Are there other things that you're left wondering about when it comes to Project 2 and the Project 2 behavior? Okay. Let's talk about the resources API. Yeah. Sorry, I'm gonna go back and forth here. Before I talk about that, I want to talk about the README and documenting your program. Okay. I think we talked about the plan of attack last time. Just a quick reminder. It's a plain text email, sort of like a normal email that's sent to me that is a couple of paragraphs about how you're going to approach your program. And this is something that I'd like you to send to me, at my whitlock@cs.pdx.edu email address 3 days before the project is due. And so that's Sunday night at 6 p.m. So there's that. Oh yeah, Java doc comments. I'm going to go to that back. I'm going to talk about README first. Okay. So every project has a README option, right? So if we go back to the command line, there's a dash README. And when dash README is encountered, all you should do is print the README for the project and exit. No other command line parsing, no other operation. Just say, oh yeah, I saw a README, print out the README and exit. So what should be in the README? The README is just a concise description of what your project does. It's more than just the command line usage. Maybe you can have the command line usage, but make sure to have additional information such as like, who you are and the name of the assignment, and then maybe a brief description of what the program does beyond the command line usage. But that's it. So the whole idea is that this is, I don't know, 20 lines of text or something like that. Not super huge, but again, more than just command line usage. Now, because this is like static text, yes, you can put static text inside a .java file inside Java source code. And actually, as we saw with the Kata and the final integration test that we wrote, yeah, now that we have the the 3 double quotes syntax and stuff, it's not awful to write big blocks of text inside Java code. But there is a better way to do it. So now I'm going to go back and look at the code. We have here our source code, and then the production code is in the main directory, and then we have the Java code in the Java directory underneath that, and then you have a file hierarchy that matches your package, and then you have your Java code in there. There's also a set of parallel directories called resources. These are source resources. And resources are static files that get included in your application. So for instance, if you have icons in your program, they would be in here. If you have media files, such as videos or audio, that get played as part of your program, those are resources, right? Because when you think about an application, it's not just code, it's code and media resources, things that things that aren't code. It's like a file that then gets read by the program, and then done something with it. Like, oh, great, here's the icon display. Well, here's the splash screen that you show when you're starting up, or hey, here's if you're doing web stuff, here's like a style sheet, right? The style sheet probably isn't dynamic, it doesn't change, it's static, and so they just read it in. Well, here in the project out of the box, there is a file called readme.txt. And this is a static file that, and I'll show this in a minute, that your program can read in and then just write it out to standard output as part of the README operation. And so my example, and the way you do that is use something called the resources API. So let's see here. I believe it is the test. Yeah, it's not that. It's I think it's a unit test. Is it project one test? Yes. Here in project one, it validates that the README file can be read as a resource. Now, you're going to learn more about this in the Java I/O lecture. So if you haven't watched that already, please go and do so because you'll get lots more details here. But the bottom line is this. Using code like this stuff that's here in the test, you can load the readme.txt as a resource, and then you get something called a buffered reader and read the first line of it. And then you'll get the first line. So here we can assert that, yep, the first line is, this is a README file, which if we then go back to it, it says, yep, this is a README file. Oh, really? Where'd project one test go? Okay, so there it is. And so now if we run this, it gets the resource as a stream relative to the project one class. So it knows to look in basically the package directory for it called readme.txt. It reads it in using an input stream reader. This returns a class called input stream, which we'll learn about in the Java I/O lecture. You wrap an input stream reader around it. You wrap a buffered reader around all of that, and that gives you the ability to read a line from a resource. This is code that I provide you that you can then adapt into your main program to read the contents of the README from a file. It's and Adam, that is my next thing I'll talk about. It's a good way to implement the README. And the way this works is that this README file is bundled into your jar file. As a matter of fact, if we go, let's go look at that. Let's go back to let's go back to Joy of Coding Summer 2026. Let's go into the airline project. And let's do a Maven package, W package. And now if we look at target airline.jar, yep, it's got an entry. So the readme.txt is in the jar file because remember, this is static text. This isn't going to change. And so it's just a text file that's bundled into your jar file, bundled into your application along with all these class files. And so you access that from the jar file by calling this get resource as stream. So this is very important to note that the get resources stream doesn't load it from the file system directly, instead loads the resource from the jar file. This is kind of a different concept because you're loading it from, again, you're not loading it just as a regular file, you're loading it from a jar file. But it's an important distinction. But hey, if you follow this, then what this allows you to do is just add your README text here to this resource file, and then you'll load it into your program. So this, in a way, is because you can do this. Actually, I recommend that you do this for project one as part of your README. This is your first introduction to sort of working with the I/O APIs, right? You see input stream and buffered reader and things like that. However, the resources, so you can use the resources API for the README. And actually, we've got another example of the resources API in the unit tests for text parser. Here, we have some test resource files, ignore the XML for this term, that has like a description of a valid airline. It just has the airline name as the first line of the file. But this is a test file. Again, it's static text. It's not going to change. We use it to test the parser. And so what the parser does is, okay, it goes and gets that resource, and then, it's got this out-of-the-box implementation of text parser that when you call the method, note that text parser, takes a reader and just reads the first line of it and returns a new airline object with that airline name. So again, this is skeletal code. You can do the rest. What this allows you to do is to write a test where you create a new text parser from the in-between reader around this test resource, parse it to create an airline, and assert that the name of the airline is ultimately created from parsing that file equals the airline name that is on the first line of the file that was parsed, test airline. So resource files are great for when you have static text, like the README or this test data. Super great there because it's bundled inside the jar file. The resource API knows where to find it. You don't need to worry about it. For the files that the user specifies for your project too, those should not be resources. Do not use the resources API for that. Instead, just use the regular file API, the Java IO file API, or if you want to use paths and things like that. Use one of those APIs instead because those are dynamic files. And those are files that reside just straight up on the file system. They're not hidden in a jar someplace. They're not someplace on the class path. Nope. The user specifies the file location. It can be anywhere on the file system. Just use regular files for that. So, Adam, that was my attempt to answer that question. Is there anything you'd like to follow up on with regards to the distinction of resource files and non-resource files, just regular files? This is a really important concept and one that admittedly has tripped up students in the past. So I want to make sure that if there's anything that you want to discuss, you all want to discuss now, that we can.
I have more questions.
Yeah, shoot.
Java is basically can be decompiled. So if you're having any type of persistent data that you want to keep secure, are you instead just calling a Java API to hash it? Because if it's in the Java program file, is it automatically hashed? Because the program source code is decompilable, but you don't want some secure persistent data to also be decompilable. How do you do that?
Well, encryption is the answer. I'll be clear for everybody, this is outside the scope of the project. Do not encrypt. Actually, don't encrypt your files, please. They have to be text files that I can read. So yeah, Adam, I think you're bringing up an important use case, although one that's not immediately applicable to this project. Just want to make that clear. But to answer your question, what you want to do is encrypt your data. So well, certainly files that are written to disk or files that are put in or data is put in a database can be encrypted, and so Java has a wide variety, has rich library support for various encryption algorithms to encrypt your data. And same thing with, let's see here, jar files. Can jar files be encrypted? Well, they probably actually, I don't know if there's a standard for doing that or not, because when you run the program, you have to specify how to decrypt the jar files. So I don't know if there's any real security in that. I mean, there would be maybe if you were like trying to transport the jar file from one machine to another machine and you didn't want to be tampered with along the way. Actually, okay, sorry, there is tamper proofing inside jar files. You can digitally sign jar files. So you can say, listen, I only want to trust code that's been digitally signed by, this entity, and you can do that. But in terms of obfuscating the code or encrypting the code, there aren't standard ways of doing that. And I mean, this is on purpose, right? You want Java code, to be platform independent. And honestly, the vast majority of code doesn't have industry secrets, and only things like cryptography algorithms. And even then, all that stuff is so out in the open anyway, because you want to make sure that the implementation is correct. And so you really want to make your implementation secure. So I know that there are requirements. We were just talking about it at work where there's a certain customer that, thou shalt, encrypt thou shalt obfuscate your code. And we're like, are you sure? Because there isn't we don't want to get into that game. Where there are other ways to protect your code while it's running, while it's in transit, if that's really a concern. But I think really what you want is you want to tamper-proof your code. So it's not so much about keeping your code secret, is to make sure that your code hasn't been messed with. And Java does provide a way to do that through.
Yeah, I just was kind of curious about these persistent data because sometimes you can hit a customer who is ladled with internal IP, and they will even push requirements to you about how to do some of these things. For example,
Yep.
like Samsung and TSMC, everything they have is like golden nuggets, so they're challenging to work with.
Yeah. Well, and yep, and that's more about data protection. And there's a lot of solutions, for that, both data at rest and data in transit. All that being able to, yep, not only encrypt things, but also make sure that, that you aren't, writing the secrets to places they shouldn't be written. The social security numbers, the credit card numbers, the health records, all that kind of stuff. But anyway, but just to be clear for everybody, for this course, for this project, please write plain text that I can see, that I can read, and easily verify that, oh, yes, after I run the command that adds, the second flight to your airline, I can see evidence that the flight has been added. Okay, so other things that I can tell that I can tell you all about resource files and regular files, or resources and regular files. Okay. Okay. So this whole this whole page, this whole PDF file is about documenting your code. We talked about the plan of attack. We talked about the README. Now I want to talk about Java comments. So well, as you might have picked up on, when we look at the student class, oops. The student class has these comments before certain program elements that begin with slash star star and end with star slash. So here's one before the class itself. It describes the class. Here's one before the constructor. It describes the constructor. It talks about what the constructor does, also enumerates all of the parameters for the constructor. And here for the methods, the public methods, same thing. We have these star slash slash and star slash comments. These comments are called documentation comments. These are special comments. So as opposed to just generic code comments that sort of say something, these comments have a certain structure, and they are meant to describe the program element that immediately follows it. And these are part of a standard called the JavaDoc standard, the documentation standard for JavaDoc. Because there is this standard, what you can do is you can then generate various types of documentation for your programs, in particular HTML documentation. So if you run the JavaDoc Maven task, it'll go through and it will analyze your code and create HTML documentation in Target. Target. We're looking for JavaDoc. Yeah. Sorry, where is it? Site. Mr. Coco. Why am I not seeing the JavaDoc? 11 warnings. Sorry, does it say in the... Well, I guess I don't have an example here. Well, we'll talk more about the Maven site later. No, yeah, we should be able to do this. Sorry. Let me clean. Let me look at the JavaDoc again. Great. Target. Oh, reports. That's where it was. JavaDocs and then index.html. Okay. Make it a little bigger. So this creates, by running the JavaDoc command from Maven task from Maven, it generates this documentation for your code. This uses a tool called JavaDoc, and I talked about it in the lecture a bit more. But what it does is it oh, how come I don't get student? Flight project 1, just getting this. Oh, I'm in the wrong directory, that's why. Jeez, Dave. I'll just do it from student. There we go. Here it is for student. So it basically goes through and looks at the source code and generates these HTML files that describe the API, the methods and the constructors and the classes and stuff for these for the code. So as you can see, well, I mean, right here, this class represents a student, and this comes directly from the Java comment for the student class. And as you can see, you can have some formatting there with like the code there, and now you get like a fix with font for that. More interestingly, it generates JavaDoc for the student constructor, again with the information from the params here from the constructor. And the whole idea here is that you want your API documentation to be right next to your code. So that way, as you change the code, the API documentation can be updated at the same time. It's all nearby. No more maintaining separate documents or having to go back and forth between the code and the documentation for the code. JavaDoc is something that I want you to get some experience with in this course. So I encourage you to read up on JavaDoc at that link. And JavaDoc and writing good API documentation is part of what I want you to learn in the course. And so the way I assess your understanding of that skill is the following. So I will run the command maven w-p grader. So it's the grader profiler for Maven, JavaDoc. And what this does with the -p grader, it outputs not HTML files, but a text summary of the JavaDoc for all of your for your code. So in this case, I'm doing it for the student project, but you can do it with the airline project also. And here it just prints out, yep, the name classes and GPA. Here it has the name. Sorry, here it has the JavaDoc comment for the class itself. And this will be one of the test cases for your program. So I expect, let's see here. Let's see here. I expect a Java comment for every class that you write and every method, every public method. Well, I'm sorry. No, every method that you write. And I encourage you, actually, no, I want you to explore the @param, the @return, @throws, these other tags that you'll learn more about here. And so then I will I'll generate this documentation as a part of testing your code. And it will count for, or rather, I reserve the right to deduct up to 1 point from your project grade if I deem that the JavaDoc is insufficient. For both project 1 and project 2, yes, every project except for maybe the Android project, except for the last one. I want you to provide API, Java comments for all your classes and all your methods. And then, if there's anything that needs to be updated from project 1 to project 2, please do that too. Oh, and here's just another note. As far as a style guide for Java, I recommend the one from Google, and so that's available here. Oops. Got really small. However, to be clear, I will not be assessing your code's compliance to Java coding standards. The only time this would come into play is if I find myself looking at your code, like debugging or whatever, and if it's a real mess, then I might, get grumpy about it, but more likely than not, this is just something I want you to learn about as part of just, developing good Java development skills. So that, in a very roundabout way, was this documenting your code for the course handout. Plan of attack, due Sunday night. JavaDoc comments as generated using this command. And then the README that prints out a concise description of what your project does. And I encourage you to leverage the resource API to load that so it can be printed. Anything else in this document you'd like me to cover? Okay, last thing. For both project 1 and project 2, I've talked about submitting. the project. Uh, Long story short, there is a submit.sh script that is included in your repository. And you need to run you need to run submit.sh on one of the CS department's Linux machines. And then the argument that you give to it is the name of the project. Project 1, Project 2, Project 3, et cetera, et cetera. And what that does is that submits the code that you wrote to me, and then that's what I can use to grade. There's a bit more. Let's see here. Submit. There we go. How do I submit projects? So then bottom line is like what I just said, use a submit program from the MKEX Linux machines, and give it the name of the of the project to submit. There's a couple of notes about submitting it. If you're debugging with print lines, please take that out before submitting it. It adds cognitive load to the grader, who this term is me, when I need to sift through a whole bunch of program output just to find like, oh, here's the error message, right? It's fine to debug with print lines, but please take them out before you submit. Either take them out or comment them out or put them behind like a Boolean flag or something like that. Submit takes, like I said, one argument. So starting with project 1, like here's how you submit it. And what it'll do is list all the files that are submitted, and it'll give you an opportunity to accept or reject it. And then what it does is it zips them all up into a file and emails them to the grader for grading. You're also, as part of the submission process, given the opportunity to provide a rough estimate of the number of hours you spent working on the project. I use this, I've gathered data about that for a while now. And so as a result, I have self-reported information about how long it usually takes to do the projects. So over the years, I've had 168 submissions for project 1. And on average, it takes 21 hours. 75% of the people take 25 or fewer hours. 25% of the people take less than 12 hours. One person took 60 hours one time. Okay. But again, on average, and the average and median are about 20, 21 hours self-reported. So please take that into consideration as you're planning your time over the next the coming week. As you start focusing on project 1. In the past, this is how long students have reported that it takes. Actually, in general, co-1 should be first, I guess. But anyway, in general, the students report that it takes around 20 hours to implement these projects. So this isn't like bang it out the night before. I do recommend that you get started on it early. Back to submitting, just some notes here. Let's see here. Only files in the source directory are submitted, and even then, only the java.java.xml and .txt files are submitted. And so then, yes, this is why I recommend that you put the README in source main resources, in some subdirectory of all that. And note that you cannot submit a modified pom.xml file. And this means that you can't add extra dependencies like, hey, can I have a third-party command line parsing library? No, even though I know you with the real world, learning how to parse a command line is part of the project. So no, you can't use a third-party system there. You may submit multiple times, and only your most recent submission will count towards your grade. But there is a little bit of overhead in grading, and so then just be judicious about the number of times that you resubmit. Hey, if you find a bug, 20 minutes after you submit, go ahead and resubmit it. But if you find yourself submitting like 20 times, then maybe reconsider your life choices. The submit script has an optional comment that you can pass along to me that I'll see when I grade it. Although if there's really something that you want to know, send me a DM and say, hey, listen, there's no bug, or like, oh yeah, I realized right after I submitted I got something wrong, I don't have time to fix it. Just let me know. It'll be okay. I guess I'd rather not be surprised by what I see. The submit script also puts a git tag on your repository for the current revision that is submitted. And note that you must commit any local changes before submitting. This way, there is like a definite point in time of like, oh yeah, here is the code that was submitted. This is helpful for a couple of reasons. Mainly, if you need to go back in time and if you need to go back in time and like fix a bug, or if you weren't sure exactly what was submitted when, this way you've got good bookkeeping there. And also, then again, if you need to create a branch, then great, you'll know what revision that is, so you can create a branch from that tag to fix a bug. Oh yeah, yeah. Also, it makes sure that you've pulled all of the changes on on the branch that you're submitting from into the local clone. I've had lots of students, not lots. I've had a number of students who've made the mistake of like, oh yeah, I'm working on my develop machine and I pushed everything up to GitHub, and then they go to submit, but they forget to do the pull. The submit script will make sure that there aren't any changes to pull. Yeah. Let's see here. Question in the chat. You mentioned to get in contact with you about testing working with AI for the projects. Is that still on the table? Sure. Yeah, yeah. Let's follow up after class, or let's follow up in on Slack about that. I'm really curious what your experiences are, and so I want to begin a dialogue with anybody who is using AI coding assistance. Again, no penalty. I'm just curious about what your experiences are like. If you're not familiar with Git tags, and you can be forgiven if you're not, they're not something that even I use that often. This is what you can do. After you've run submit.sh, I recommend that you push all your tags up to GitHub so that GitHub can see them too. You can do that either all of them or just like the one that was most recently added. And then here, if you need to, is how you can go about branching from a tag so you can go back and fix a bug in project one, even though you've already moved on to project two. And if you find yourself having to do this and if you have questions or running into problems, feel free to reach out. This is kind of bonus Git stuff, but it's good stuff to learn. And that's all I wanted to say about Submit. Honestly, all you really need to know in all of this is just run the submit script with the name of the project, and no space here, just project one. Okay, and I think that is everything that I wanted to cover tonight. Yes. And we are a little over time. Thanks for staying an extra minute. Just wanted to remind everybody again, please come to class, be here in person. I'm looking forward to seeing you all, meeting some of you in person for the first time, and having a in-person pair programming experience. Bring your HDMI adapter, and look forward to seeing you all then. Have a good one, everybody.